50 years ago, researchers lowered a camera to the sea floor near the Galapagos Islands and found something that should not have existed. A thriving ecosystem 2 kilometers below the surface, in total darkness, at temperatures capable of melting lead, entirely without sunlight. Life was not supposed to be there. How much of what science thought it knew about where life could exist was actually true? 8 organisms. 8 different answers to the same impossible question. Scaly-foot Snail. There is only one known organism on Earth that has successfully synthesized a metallic skeleton. 2.5 kilometers beneath the Indian Ocean, the Kairai vent field operates as a deep-sea incinerator. Fault lines expel 400-degree fluid, saturated with toxic heavy metals, directly into freezing seawater. Under 2,500 tons of hydrostatic pressure per square meter, standard biological tissue simply dissolves. Bone shatters. Chitin cracks. The scaly-foot snail bypasses this organic vulnerability through metallurgy. It discards the fragile calcium carbonate used by every other gastropod. Instead, it absorbs toxic iron sulfides directly from the lethal vent plumes, processing the elements internally before extruding them as greigite, a highly magnetic iron. It plates its foot with thousands of overlapping sclerites. This is a localized smelting operation. It deflects both the thermal shock of the vents and the kinetic force of abyssal predators by functioning as a living forge. Antarctic penis worm. Beneath the Antarctic ice shelf, the ambient salinity forces the ocean into a liquid state below the freezing point of blood. In this hyper-chilled brine, standard metabolic enzymes seize. Normal biology crystallizes and fails. The Antarctic penis worm dominates this stasis. Reaching 20 centimeters in length, this half-billion-year-old predator saturates its tissues with antifreeze proteins. While its prey is paralyzed by the thermodynamics of the frost, the worm retains full fluid mobility. It operates as a hydraulic machine, deploying a retractable pharynx lined with chitin hooks to harvest flesh made brittle by the cold. As a blind deep-sea hunter, its grotesque name is merely a post-mortem distortion. Dragged to the surface, the sudden loss of abyssal pressure triggers a catastrophic hydraulic blowout. The body violently everts into a rigid cylinder. We named a perfectly calibrated prehistoric killer based solely on its explosive decompression. Brine Shrimp. In isolated, evaporating desert lagoons, the water becomes a saturated chemical trap. Osmotic pressure here pulls water directly from living cells. Drifting comfortably in this hostile brine is a translucent crustacean barely 15 millimeters long. To survive this liquid desert, the organism functions as a microscopic desalination plant. It swallows the lethal salt water. Its hyper-efficient gills pump the salt back out against massive osmotic resistance. It burns phenomenal metabolic energy to prevent its internal fluids from crystallizing into pure salt. It survives a toxic environment not by adapting to the poison, but by perpetually bailing out a sinking ship. Sulfur Molly. For most vertebrates, hydrogen sulfide is a lethal neurotoxin, and exposure means immediate central nervous system collapse. In the toxic, isolated sulfuric springs of Mexico, this gas saturates the water. When its ancestors became trapped in these waters, the environment systematically wiped out any fish with standard biology. The survivors were the genetic anomalies. Over countless generations, extreme environmental pressure forced a physical mutation. They developed enlarged heads and expanded gills to extract whatever oxygen remained. Their DNA underwent epigenetic shifts, fundamentally altering their receptors to prevent the sulfide from binding to their proteins. Mariana Snailfish. 8 kilometers down in the Mariana Trench, hydrostatic pressure exceeds 800 times the atmospheric baseline. At this depth, physics actively disassembles biology. The pressure physically forces water molecules into cellular proteins, unraveling their structure. Deep-sea research links this survival to a 20-million-year-old frame shift mutation in the bone calcification gene. This defect meant the skeleton never fully hardened, the skull incompletely fused, riddled with anatomical gaps. Lacking rigid internal structures or hollow cavities, there is nothing left to crush. Its cells are supersaturated with TMAO, a chemical scaffolding that physically holds its proteins together against the pressure. It is a gelatinous ghost, thriving in an environment designed to crush it into paste. Pompeii Worm. The Pompeii worm fights a different war. It inhabits the crumbling chimneys of hydrothermal vents, a habitat of sudden, lethal temperature gradients. Normal biological organisms cannot occupy two entirely different thermal realities simultaneously. The Pompeii worm ignores this. Its lower half is anchored into 80 degrees Celsius exhaust, temperatures that instantly denature normal biological proteins. Just 2 inches away, its head hunts in the 20-degree ambient ocean. It survives this immediate 60-degree delta by cultivating a biological shield. The worm secretes mucus to farm a fleece-like carpet of extremophile bacteria across its back. This microbial layer functions as an active thermal buffer and a chemical filter, neutralizing toxic heavy metals before they breach the host's skin. Every organism so far fights its environment. A microscopic entity drifts in suspended vacuum, indifferent to heat, cold, or toxicity, waiting to outlast the physics of this planet entirely. Sahara Desert Ant. At high noon, the surface of the Sahara Desert reaches 60 degrees Celsius. This is a thermal graveyard. At these temperatures, the lipid bilayers of cellular membranes begin to dissolve, and standard neural pathways physically cook inside the skull. When the heat forces every desert predator into the shade, the Sahara Desert Ant steps out into the solar furnace. It operates on a strict metabolic countdown. Its entire anatomy is calibrated for thermal deflection. Silver hairs deflect solar radiation. Unusually long legs elevate its vital organs above the lethal sand boundary layer. It sprints across the dunes to scavenge the corpses of insects that succumbed to the heat. It navigates by polarized sunlight, an internal dead reckoning compass, calculating the most efficient vector back to the nest. It has mere minutes to execute the mission before its own brain begins to boil. Tardigrade. Every organism on this list is locked in a localized war with Earth's physics. They have engineered brilliant, brutal mechanisms to survive boiling vents, abyssal compression, toxic gas, and freezing ice. One does not. The tardigrade can simply pause its existence. When exposed to the vacuum of space, lethal cosmic radiation, or temperatures approaching absolute zero, it initiates a mechanical protocol called cryptobiosis. It retracts its legs, expels nearly all body water, replacing it with specialized proteins that physically prevent its cellular structures from shattering. It drops its metabolism to 0.01% of normal. It ceases to be an active biological organism and becomes a suspended structure of organic glass. In this state, time and physics no longer apply. It simply waits. The rest battle at the edges of survival. The tardigrade drifts in total stasis, the ultimate observer of a hostile universe.